welcome to today's workshop, Intro to Augmented Reality here at CircuitStream. I'm Luciana Fortes, your host for the day. Let me know in the chat if you're here, if you can see me, if you can hear me. Let's get the conversation going, and let's do our audio and video checks. I'd love to know who's there. So one thing that I love to do as well is to get some emojis going so we can get some, excuse me, everyone, just a second. Sorry about that. Got to do some more vocal warm-ups, just some like la 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 la. I got to do that. Anyways, yes, get some water. I got to do that. We should do some vocal warms up together. Woo, woo. Anyways, hi everybody. Thanks for tuning in. Great. I see you all tuning in. All right, so you can hear me and you can see me, which is great. Some people are already letting me know where they're tuning in from. So definitely do let me know. Last week I was in Calgary, but now I'm back in Vancouver. So I see that Licia is tuning in from Paris. Amazing. Hey, Rita, we had you at our last workshop from Portugal. And then Carlos from Mexico. Thanks, Brandon, for confirming that my video is working a little bit better. I'm here at this fancy office today. So there you go. So definitely keep letting us know where you're tuning in from in the chat. It's always awesome to see, where our global team of learners is tuning in from. So as I mentioned, today we're going to be talking about Intro to Augmented Reality. I'm going to get some water, actually, you guys. I'll be right back. Sorry, just 1 second. 1 second. All right, everyone, I'm back. So sorry about that. I really needed to get some water. So that was just a quick water break for everyone. So again, welcome. Today we're going to be talking about Intro to Augmented Reality. So how to use Unity 3D to build a game design similar to Pokemon Go. I'm your host for the day, and we also have Jerry Medeiros. So welcome, everyone. So continue to let us know where you're tuning in from. And then feel free to use the chat to engage with each other during the workshop. As you know, most of you already know if you've been to our workshops before. And you can also use the chat to send comments during the workshop as well as network. So feel free to drop your LinkedIn profile, and then that way we can stay connected even after the workshop is done. All right, so I'm going to go through a couple of housekeeping items. If this is the first time that you're watching, you're participating in a workshop with us. So all of you are familiar now with the chat function. But if you go to the top, you'll see that there's another tab called questions. So throughout the workshop, if any questions come up, definitely drop them there, because at the end of the workshop, we're going to have a designated time for a Q&A, and we're going to go through all of those questions in an organized manner. So you can vote on your most favorite questions, and then we'll answer those first. So it's really the best way for us to go through those. And then to the right, we also have our polls tab. So I'm going to be launching 2 polls at the workshop today, just to get a sense, just to gauge you guys, see what your experience is, what you're thinking, and then that way we can make sure that our content is relevant to you. So there you go. All right, well, thanks again for bearing with me. We've done an audio check, we've done a video check. I'd like to do a wave check that's very serious. So check, 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 wave check, done. Everybody can see the wave. If you can do the wave at home, good for you as well. So that's all good. Do bear with me. I think my voice is not 100% today, but we'll do our best. All right, so without further ado, let's get things started. So what can you expect for the day? We're going to start with a brief introduction about who we are and what we do. And then I'm going to invite Jerry up on stage to do a technical deep dive. He's going to talk about AR. And then we're going to go to a couple of wrap-ups and resources before we go to our live Q&A session. Depending on where you are, you know, in terms of we're in various time zones, so you might have to maybe go to sleep or go to work. So if you have to drop out of the workshop early, don't worry, because we will be sending the recording to all of the registrants, as well as the project files and resources via email. I see that some of you have already done the wave check. You're doing the wave, so awesome. I think we're good to go. All right, so let me tell you a little bit about myself. So my name is Luciana Fortis, but you can call me Lucy. And I am the Student Experience Coordinator here at CircuitStream, also known as, you know, Fun Guru, you know, Best Experience Specialist. You can take your pick. So I've worked with education for over 7 years in university prep, as well as student experience. And a fun fact about me is that both of my degrees are in dance. And in 2016, I danced in the opening ceremony of the Rio 2016 Paralympic Games. So if you have any dancers out there, any, you know, athletes out there, oh, I love that face. Definitely drop it in the chat. All right, and then a little bit about our expert for the day, Jerry Medeiros. He's also a fellow Brazilian like myself. He's the head of education at CircuitStream. He has over 10 years of experience in the industry. He's a university certified expert programmer and instructor, and he's a game and Xor developer. Yes, some more dancers out there, awesome. I don't know why I did that. This is the dance move for the workshop today. Jerry has some fun facts as well. I don't know why he didn't include it in this slide. He can tell you more about it, but it has to do with rock climbing and being a diver and doing yoga. So if you have any questions about that, you know, definitely hold on to them for the Q&A session. All right, so let's expand the conversation a little bit and talk about CircuitStream. Who are we and what do we do? So we were founded in 2015 when we noticed a gap in the education world in terms of training the next set of XR professionals, enthusiasts, amateurs, take your pick. So we're really proud to say that since then we've trained over 35,000 learners. I always get impressed with that number. It's really great, and this number is growing, you know, exponentially. Every second. So that's really exciting. We are a Unity authorized training partner and channel partner. So Unity partners are picked based on expertise and focus on quality education, and also on partners who are committed to giving the best training possible. So we're really proud of that. Unity covers 60% of the market, and that's our main, you know, the main engine that we work with the most. And we have a really close relationship with them. So recently we just launched a blog post where we talked about how they launched a blog post, where we talked about, you know, how our courses prepare for their certification. So that's really exciting. And we are also an Oculus ISV and Microsoft Mixed Reality partner. All right, so what about the rest of our team? So as you can see, as our similar to our learners, we are a global team of industry experts passionate about building AR and VR products. So we have, you know, team members all over the world. We come from diverse backgrounds and experiences, but we're all passionate about one thing, and that's to train the next set of XR enthusiast professionals, amateurs, take your pick. So as I mentioned, we are Unity, a Unity partner. So our team is a certified expert, certified professional, and authorized training partner. So that's something we're really proud about. And here you can get a snapshot of some of the students that we had the pleasure to train. So we have some from, you know, some really big companies. And also what I'd like to point out is that they're from various industries. So it's great to see the different applications of XR. So in addition to our workshops, how do we train our students? So we offer workshops on a regular basis, on a weekly basis, but we also have our academic offerings. And we have 3 flagship courses. So first one is the Xor Development with Unity. That's a 10-week course, 40 hours of instruction. And this is a beginner-friendly course, so you don't need Unity experience at all. I'm going to be talking about these courses in more detail at the end, but I just wanted to cover them quickly so you all have a sense of, what Circuit Stream does. And our next cohort is on July 6th. And then on September 14th, we have our next cohort for the Xor Project Accelerator. So it's more hours of instruction, almost as long, so just 8 weeks long. And this one is advanced, so you do need Unity experience. And this is focused really on a project that you'd like to develop. And then our third long course and flagship course is the Interaction Design and Prototyping for Xor. We've just recently launched this course, and we have our first cohort coming up next week on June 14th, on Monday. So we're really excited to get that started. It came from a lot of demand. It's become, really popular. People are really excited about taking this course, and so are we. So there's no more time to sign up for the June 14th version. But if you're interested, we do have a next cohort coming up on August 23rd. So this one is beginner friendly as well, but there's no programming involved. It's more focused on the design aspects of Xor. So all of these 3 courses, they include one-on-one support and mentorship, with an industry expert. So in addition to the community feeling, to having classes in a group setting, you also get personalized attention from an expert, really catered to your needs. And in addition to these 3 courses, we also have a smaller course, C# course, which is going to be 4 weeks. And that's really to give you the basis of the C# programming language. All right, so closing up the academic portion, we also offer team training to educators and businesses. So that's all customizable, and you can talk to one of our learning advisors to get a sense of what would be available for you and your company. All right, so let's start diving into the workshop today. What are you going to learn? So you're going to learn how Unity is used to build AR, so augmented reality apps, major AR and VR virtual reality development tools, how to track planes in AR, how to place virtual objects on real environments, and answers to your questions. So bring them all, do not hold back. All right, so let's touch base about Unity. So as I mentioned, we are a Unity certified, Unity partner. We cover Unity in our courses, and we're going to be covering Unity today. But let's first get a sense of what your experience is with Unity. So I'm going to launch our first poll of the day. And I'd love to know how much Unity experience do you have on a scale of 0 to 10? All right, so the poll is published. So if you could go ahead to the polls tab and vote, that would be awesome. And then we can get a sense of kind of where our crowd is. All right, so let's start seeing some of the results. So we have about, wow, okay, so 40% is 0, which is totally fine. So this is a super beginner friendly workshop. And then we have about 25%, that's 1, 3. All right, we have 4%, that's 8, and 10. Oh, 10, you're gonna be an expert. You can give this workshop for us. But anyways, I see that most of the students are beginners, which is perfect, so this will be great for you to follow along, and you'll be learning a lot. All right, so let's start covering what is Unity. So Unity is a free 3D development engine for building games, simulations, and experiences. So it's the easiest way to begin making apps for XR, which means extended reality, which is just a fancy umbrella term for AR, VR, and MR, which is mixed reality. So there you go. So how do you go about building an app on Unity? So it all starts with your idea, and then you create it in an engine such as Unity, and then you push it out to one of these 3 SDKs, such as Oculus, Steam VR, and Microsoft HoloLens, and then again to the device that's compatible to each of these. All right, so without further ado, I'm going to stop babbling. I know you're probably like, Jerry, where's Jerry? Bring us Jerry. We want Jerry. So I'm going to give the people what they want, and I'm going to invite Jerry up on stage to go through the technical portion of the workshop. So, there he is.
Hello.
Hey.
Everyone, can you guys hear me and see me just fine? Just say yes there in the chat. And it can get started. All right, perfect. Cool. So yeah, let's get started. Let's get into it. All right. So if you're a complete beginner, and I've seen there in the poll that most of you guys are, fear nothing. We're gonna go from the very beginning here. We're gonna need some coding, but I'm gonna make sure I go slow there and I explain what's going on. But before we join into the 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 Unity part of things, let me just show you guys what we're gonna be building and how, and then we can get started. All right, so let me just present my screen here real quick. There we go. So today we're gonna have an intro to augmented reality. So what is augmented reality? Anyone there in the audience that can try to describe that for us? What do you think augmented reality is? Anyone? Let's see. I see some people typing there. 3, 2, 1. Snapshot filters. That's one way of doing it. Enhancing reality. That's another way of doing it. Integration of virtual objects in the real world. Yeah, we're getting closer. New layer to the world. Perfect. VR environment that has tangible objects in real world. Oh, that's a good way of putting that. Mixing digital. All right, perfect, great. All great answers in that. So yeah, that's it. Basically, technological addition to our perception. That's a really fancy way of saying it. But yeah, all of those answers are correct. Basically, augmented reality is most of what we're seeing is still reality. So we're interacting with the real world, but we are overlaying digital content on there. So we're just like adding a new reality to our own. What we're going to be building today, is something like this. It's basically like a simplified clone of Pokemon Go. I am not using Pokemons there just because of IP. I don't want to be sued and anything. So we're going to be using a different module. But basically, what I want to teach you how to do today is basically identify planes, like things that exist in the real world, and overlay this monster there. And we can like just throw the ball and try to catch them. So it's basically inspired on Pokemon Go, a little bit simplified for us to be able to do it in 30 to 40 minutes here. But that's basically what we're going to be building. And the way we're going to build it is using AR Foundation. So what is AR Foundation? It's basically like a high-level technology that Unity developed for us to be able to develop AR in different devices. So it's cross-platform. It's super cool because you can write your application once and deploy it to Android, iOS, HoloLens, Magic Leap, or whatever exists out there. So it's really cool because we don't need to know about the specific things for simple platforms. The way it works is basically in the XR stack in Unity. It seems complex in the end, but basically it is like this. For it to work in every device out there, they have providers. It's basically like plugins or native implementations. We don't need to know what those things do. They are just basically like helpers, but we need to enable them. So if I want, for example, to publish it for Android, I will need to enable this AR core. If I want to publish for iOS, I will need to enable the AR kit. But we don't need to know what they do with the device. They basically just communicate with the device in a nice way. Then we're going to be developing here on top of everything. So the only thing that we need to learn is AR Foundation and the systems that are existing there. So all of the subsystems in AR Foundation, we can access them in an easy way. They're going to be translated to the device. So that's basically what we're going to be doing. The only concern or the only consideration is basically what is available for every platform or for each platform out there. And this is because the hardware is different. So some things are not available on Android. Some things are not available on iOS. And this is because the device doesn't support it or the technology there doesn't support it. So today, we're going to be doing device tracking. Basically, I want to know if my device is moving so I can see different perspectives of the world. It's supported for Magic Leap, HoloLens, AR Core, and AR Kit. So it's fine. We're going to be using plane tracking. As you can see, it's not supported on a HoloLens, but that's not a problem. We're not going to be using HoloLens today. But this is the only thing that we need to take into consideration because the devices, they are a little bit different. So you can write something in AR Foundation and use that for every single platform out there. This is fine, but you need to take into consideration the environments in there. So that's the only thing that I want to call out here, and then we can get into Unity. So that's what I'm going to be doing right now. I will share my entire screen again. This one here. Oh, good. So do you guys see Unity there? Thumbs up if yes. Okay, I see thumbs up. That's good. Perfect. So this is Unity. This is the tool that we're going to be using today. It's a game engine. So it's basically a tool that allows us to develop any kind of application, game, 3D, 2D out there. It's really, really complete. If you have never seen Unity before, it's divided in some panels. So those panels are basically our workspace where we're going to be doing stuff. The most important ones here that we need to take into account are, first one, this one that is called the scene view. This is the representation of the digital or the virtual world in here. It's like our world. We're going to be adding objects, adding lights, adding the sky. As we can see here, by default, there's a sky. So this is basically our level, our scene, the place where we place our objects. Here on the left, we have the hierarchy. So this is the same as the scene, but seen in a different way. Instead of seeing like it visually, we just see that as a structure. So I know, for example, that there is a camera on my scene. There is a light on my scene. Everything that we add to the scene is going to appear here in the hierarchy as well. It's called a hierarchy because I can make like one object a child of the other, and then everything that I do to the parent is applied to the children as well. We're going to see that in a while. Here on the bottom, we have, before we go to the bottom, when I select something like the camera, in this tab here, the inspector, I can see all of the properties about this object. So for example, I selected my main camera. I can see the position, the rotation, the scale, parameters about how far this camera can see, a bunch of stuff about camera. If I select the light, it's the same. So I can change the color, the intensity, and a bunch of things about the light. So the inspector is where we added the properties of the objects that we have in our scene. That's it. And here on the bottom, we have, last but not least, the project. So the project is basically where we are going to have all of our assets. Assets is basically the things that we use to make a game or an application. Image, 3D objects, scripts, everything. So we're going to be creating our structures here. All right, so this is Unity, pretty brief introduction in there. I'm using today Unity 2020. So if you want to replicate that later there, I suggest that you use the same version. Well, you don't need to use exactly the same version, but at least you need 2020. Cool. So now let's start preparing this project for AR. As I mentioned, we are going to be using AR Foundation, right? So I need to import AR Foundation here. The way we do it is using the package manager, or the Pac-Man for the friends of it. So we're going to go to Window, Package Manager. The Package Manager is basically a system in Unity that allows us to install stuff, like additional stuff, things that don't come with the engine. Basically because not everybody's going to be developing AR. So why do they need to have AR Foundation? So they don't. We just go there and install it. So to install that, the first thing I need to do is just check in here or change in here from where I want to get the packets. So I don't know why mine by default is showing me only the ones that are already in the project. That's not what I want. I'm going to click here and change it to Unity Registry. So now I have access to every single package out there. We can just search for the one that I want. The one that I want is AR Foundation. So you can see that it's right here. After you locate it, you just hit install and wait a little bit. It's going to install AR Foundation for you. And it's going to make it possible to have AR features in this project. It usually don't take that long, usually a couple of seconds, and then we can move forward. I see that Frida's typing. Let's see if there's a question there while it finished importing. No. Is Package Manager free too? Oh yeah, it's free. It's free. Yeah, it's definitely free. This is official thing for Unity. It's just to avoid us to having like a bloated application with things that we're never gonna use. So if you're not gonna use AR, you don't import it. If you're not gonna use 2D, you don't import it. So the Package Manager is free. It's just like a way for us to get access to different species of features when we need them. All right, so now that I have AR Foundation in my project, I need to make a couple of settings here before I get started. So the first one is, considering that I'm gonna be building this for Android, I need to go on File, Build Settings, and then change my target here. Because by default, Unity assumes that my application is PC standalone, but it's not, it's Android. So I'm gonna go to Android and click on Switch Platform. So now I am just telling it that this is going to be Android. And yes, you'll be receiving the recording after it and also the project. So you can go over this a little bit slower, repeat it, reproduce that. So if I go too fast here for you to keep track there, don't worry, you're gonna receive the recording there. All right, so now I am on Android. That should be enough, but unfortunately, it's not. So if you're developing for Android, there are two things that we need to change here. I will click on Player Settings, and this is gonna show me a lot of different settings. If you are working with AR and Android, there are two things that we need to change. The first one is remove the Vulkan API here from the list. So what the heck is Vulkan API? It's basically like a technology that draws stuff on the Android. Only newer Android has this thing, but AR Foundation doesn't support it. So we cannot build this on the Android later here if we don't have it. So I'll just remove it. The second thing that we need to do is change the minimum API level. So this is basically the version of Android that is going to support this application. AR is only supported after level 24, actually 24 included. So I would just change and say that my minimum API level here is 24. So now that's almost it. The last thing that we need to do is enable the plugin. Remember that I told that we can use only AR Foundation, but we need to enable the providers. So to do that, we're just gonna go on our player settings again. So I'm gonna go here on Edit, and then Project Settings, Player. It's the same window that we were. I'm just like showing another way of getting there. And we're gonna find this XR plugin management. Here is basically where we enable plugins that we need to use. So if you install, for example, iOS, you're gonna have it here. In my case, I am on a PC, so I cannot build for iOS. That's why I'm gonna be using Android. I need to enable AR Core, and that's it. So as soon as I click AR Core here, my project knows that it can make the AR work on Android devices. If we're planning to build for iOS, you just need to go there and enable AR Kit. It's almost the same thing. If we're doing that for the HoloLens, you can just enable the Windows Mixed Reality, and there we go. So you basically just need to enable whatever you are using. In our case, just AR Core, because it's going to be built for Android. All right, so this is a bit annoying. Those things are not cool, not interesting, but they are necessary. Now we are ready to go. We can basically just do whatever we need to do here, which is creating our project. So the first thing that I'm going to do is removing this camera. Why I'm going to remove this camera? Because this is a virtual camera. It only exists, or it only makes stuff here in this in the scene, like only in virtual environments. But actually, I want to make AR, so I need to see the world. I need to use like a camera that can capture from the mobile camera. So I'm going to remove this and add another thing here. So I'm going to right click. Because we installed AR Foundation, we're going to see XR here, and I will add an AR session. So what's an AR session? it's basically the object in AR Foundation that enables AR. It's going to request access to the camera, start AR, and everything. So for every AR application, we do need to have an AR session added to it. The second thing that we need to do is add the AR session origin. So the AR session origin is another automated thing here in Unity that's going to track the position of our device. So if I move my device around my room here, it's going to track that and move this object as well. As a child of this object, and now we can see like the hierarchy, we have a camera. So that's why I deleted the first one. But this is a special camera. This is an AR camera. It comes with a pose driver. That's basically like something that tracks the position, camera manager. So there are a couple of components here that we don't need to know what they do, in details. But what they're doing is basically like getting the image from the camera and rendering them, overlaying the digital content in there. So that's basically what we need to do. This is already an AR application. If I build this, it's going to request access to the camera, start the camera, and that's it. It's going to start to work just fine in there. But now we want to place our monsters, right? We just want to like to place our small monsters in there. So how do we do it? We will need to detect planes. So basically, say for example that we have our environment here, like our environment is just right here. We have the mobile phone pointing to the environment. We want to place a monster here. So we need to identify that this plane exists. The way it works is basically on image processing, the camera is going to try to find the planes, and it's going to find like small planes that grows bigger and bigger until we have like the entire environment detected as a plane. So that's the first thing that we need to do in our application, make it possible to detect those planes. For it to work, it's pretty simple, pretty automatic. We just need to add one object that is called the AR Plane Manager. So the AR Plane Manager, we need to add that to the AR Session Origin here. So I will select the AR Session Origin, click Add Component, and search for AR Plane Manager. AR Plane Manager. That's it. The plane manager is going to automatically start to track planes. It's going to find planes in there, and we will be able to use those planes. We can check what kinds of plane we're going to find. So say, for example, you're not going to place anything on the walls. You can just like use only the horizontal ones. Or if you only want to use the walls, you can use the vertical ones, or you can use everything, and that's it. So I will keep everything in here. But you can adjust that based on your specific application. All right, so now that we have the planes, that's perfect. They're going to work. One thing that I like to do while I am developing is visualize those planes. I want to see where they are so we can debug and see if it's finding the planes just fine. In production, like when we're going to publish this and make money with this game, we're going to disable that. But for developing, that helps. So everything that we need to do is basically having a plane prefab here. The way we do it is we right-click, XR, and select AR default plane. So this AR default plane is just an object that is going to draw a plane for us. So it's going to draw a plane with a fixed color that we can customize. But because we're just testing, this is fine. We don't need to change it that many. Then I will select the AR session origin again and drag this AR default plane right here on the plane prefab. So what I'm telling the plane manager to do is every time that we find a plane, draw it for me so I can debug. I can see if it's good, if it makes sense, if my application is working. Oh, good. Thumbs up there if it's going fine, if you guys are with me. Okay, I see lots of thumbs up. Perfect. All right, so let's move forward. So now we will need to write scripts. Yay. Where did the default plane come from again? Sure. So you right-click XR AR default plane. That's where it comes from. Perfect. All right. So now we need to start writing scripts. So yay, this is the most exciting part. I know that some people don't like writing scripts, but I promise it's cool. So the first thing that I'm going to do is here in our AR session origin, I want to write a script that is going to, if it finds a plane, create a monster for me, create a Pokemon there for me. So that's our first step. How do we do that? We need to create a script first. So I will create a folder. Oops, no, that's not what I want. Right click, create folder, scripts. It's not necessary, but I like to keep everything organized. So I have just now a folder called scripts, and I will create my first script here, C# script. So right click, create C# script, and I will call it generate random monster. Now that I have this script, yay, it doesn't do anything. We need to make it do something. But first, every time that we have a script, if you want this script to run, we need to add it to any object in the hierarchy. If it's just here in the project, it's just a file, it doesn't do anything. So I will select my AR session origin and drag this script here. Oh, I misspelled that. Not gonna fix it, but yeah. I'm pretty sure you guys are more attentive than I am. All right, so now we have this script. I can double click it and start interacting with it. We're gonna write some code here. As soon as it loads. So, okay, there we go. It's loaded. All right. So here, every time that we create a script in Unity, it's gonna look like this. We have a public class, which is basically like representing this script. It has a name. It's gonna come with two functions, the start function and the update function. Those functions are really important. They're basically like some events that are automatically dispatched or called by Unity when something happens. The start is called just once when we hit play, when we start our game. And the update is called every time, every frame. So if my application is running at 60 frames per second, the update is going to be called 60 times per second. So our initializations we do here, the logic of the game we usually do here. So those two functions are really useful in there. So the first thing that we want to do here is basically detect those planes. Remember that we now have the plane manager detecting the planes for us. We need to be able to detect them somehow and to interact with them. So for that, we need to have a reference to the plane manager. And this is the first thing that I'm going to do here. I will create here a public AR plane manager. Plane manager. So what does this line do? Creating, actually, it's AR. It is creating for us a new variable. A variable is basically like a data holder. It's something that I can keep an object or a value in. The way we declare a variable is always like this. Whether it's public or not, public, it means that I can access it from anywhere. The type that it's going to hold, the type of the data, and the name. When we want to use variables that are like complex types like this one, it's not a number, it's not a text, it's an AR plane manager. We need to tell the application where to find it. So the easiest way of doing that is just using Visual Studio here to solve that for me. So if you hover that and click on this thing, it's gonna tell that the reason why it's outlining in red is because I'm not using or importing the right thing. So I'll just click here, using Unity Engine XR AR Foundation. Done. So now I have a reference to this thing. Another variable or another thing that I want to take control here is I don't want to instantiate, for example, two monsters in the same plane. Like I don't want to have two monsters at the same time in the same plane. This is a condition that I created. Maybe you want to do that, but just to use more variables here, let's assume we only have one. So I will need to have another variable that does the same thing, that just holds a value. This time it's going to be a bool. What is a bool? It's a type that says it's true or false. It's basically yes or no. And I'll call it monster exists equals to false. So now I have two variables. One is a plane manager, another one is a monster exists. Those are the only two variables that we need in this script here. One super nice thing about variables in Unity is that when we create it, like when we create those variables here and they are public, if I just go back into the Unity editor, in the place where we added that script, so if I select here, for example, my AR session origin, the AR session actually, we are gonna see here that we have a reference to the plane manager, because that's the variable that I created, and the monster exists, another variable that I created. This one can be true or false. So if I check, it's true. If I uncheck, it's false. And this one can only be a plane manager. So I need to drag the plane manager here. Where the plane manager is, it is in the AR session origin, right? So I just need to go there and drag the AR session origin here. So now the value of that variable is basically the AR session origin that I have in there. And cool, I can go back to my script and now make it do it do something. Like I can just write one thing. All right, so what I want to do here is it's going to be identifying planes. And as we already know, it's going to find many planes. Yeah, in my drawing there, it's going to find many planes until it is actually a big plane. So we need to consider that multiple planes exist. Those planes can be accessed in the plane manager. So if I just use here, plane manager dot trackables, this is a list of planes. The trackables are basically the planes that are being tracked in this specific moment in time. Remember that this runs every frame. So basically, this is going to be tracked every time in there. All right. So considering that this is many planes, not only one, we need to loop through them. We need to go over every plane that was detected. The way we do it in C# is using a for, and we can use actually a for each. So what is a for each? It's a structure in C# that's gonna go for each something. So it's gonna do whatever I write here for each object that I tell it to track for me. So the way we do it is something like this. Let me write it and then I will explain it. Plane manager dot trackables. We already know what the trackables are. So basically, what I'm telling the script to do is for each plane that exists in the trackables. Trackables is a list of planes in the plane manager. Call whatever is here. Remember that I told you guys that the planes can be vertical, horizontal. We can have like planes in the walls, in the ceiling, everything. I only want planes that are horizontal and align up. I don't want to place like a Pokemon on the ceiling. Otherwise, it's going to be like upside down. So I just want to use like tables, my couch, the floor. The first thing that I need to do is to test what is the alignment of this plane. So every plane is going to be an alignment. It's going to have an alignment. And I just need to check what alignment that that thing is. So again, to use the plane alignment, we need to import something here, which is the subsystems. Remember that we had AR foundation, all the subsystems and everything. One of the subsystems is basically the AR subsystems that has like the planes, the faces and everything. So I need to import that. Just use the Visual Studio for it. And now I have like all of the options for the alignments. Horizontal down, it's basically like the ceiling. Horizontal up, everything that is pointing up. So for example, the floor, the table. And we have vertical and like weird planes, like perpendicular planes and other weird planes. So right now for this application, I only want horizontal up. It's basically like only take into consideration applications or only take into consideration the planes that are facing up and they are horizontal. So that's basically the first check that I'm doing here. The if statement just checks if this is true or not, whether the alignment is equals to horizontal up. And one thing that we need to notice is that to compare the left side with the right side, we need to use 2 equals. Why? Because if we use only 1, it's an attribution. So I'm just saying that this is equals to that. If I want to ask if this is true, like, is this equals to this, I need to use this. Otherwise, I'm just like changing the value of the alignment. That's not what we want. And here we're going to be creating a monster, right? So I already know that I only want to create a monster if another monster doesn't exist already. So I'm going to check here if monster exists is equals to false. So if no monster exists, we create our monster right here. All good. Cool. So now we just need to create this monster. We just need to make this monster appear on the screen. So for that, we need to have a reference here to this monster. We need to tell what is the monster that I want to create. So I will need another public variable here. So a public game object in this case. What is a game object? Anything that can be created in the level. So game object is the most generic type in Unity. Everything that is in the scene is a game object. So I will just create here a reference to a game object, call it monster. And that's it. So now we need to give it a value. I'm going to go back there in Unity. You guys can see that now there is going to be one more option here, which is the monster that I want to create. And I just need to drag it here. You can drag anything. I'm going to be using one of those monsters here that I've got from the asset store. So they are like box monsters. I think they were free, so you can just like use them, or you can find any others on the asset store out there as well. So basically, I'm going to be using one of those monsters, One thing that I would like to highlight here is that remember that we are making things in AR, right? So they're going to be instantiated in the real world. So we need to pay attention to the scale. Those monsters, I already changed the scale of them to 0.2. So this is in centimeters. Actually, Unity uses meters. So 0.2 is 20 centimeters. For you guys in the US, they're not familiar with meters, with the metric system. You're going to maybe have some trouble with Unity, but that's what it uses. And I'm just making this guy be like 20 centimeters when I instantiate them in my room. This is really important. If I use 1, for example, it's going to be 1 meter. So it's going to be like how much, like half my size. So we need to be attentive to the scale when we are dealing with AR. So that's it. I made them all 0.2. I will select my AR session again and drag any of those monsters here. So for now, let's just use this box mon here. Later, we can like make a logic to randomize among them. But right now, just to keep it simple, let's use this one. So now we just need to basically create that monster. So we need to create them here. How do we create a monster? There is a function in Unity that is called instantiate. This function is really useful and really nice. What it does is just basically like creating something in the scene for us via code. So it's basically the same as doing this here, like dragging it. It just instantiates the object for us. But why we cannot just drag it? Because I need to create that in the plane that was identified. So we need to use code. The first thing that I need to do here is basically say what I want to instantiate. In my case, I want to instantiate the monster. So basically, it's instantiating the monster for me. When we don't say where, it's going to instantiate in the 0, 0, 0, in the origin of the word. That's not what I want to do. I actually want to instantiate that in the position of the center of the plane, right? I want to instantiate that in the plane that was identified. So it's going to be on my couch or on my carpet, whatever you want to, whatever plane is identifying in there. So I will just get the plane center here. So to get the plane center, we will need to actually create another variable here that's of type vector tree. what is a vector tree? Vector tree is basically a structure that defines X, Y, and Z. So I'll just create this here as a vector tree center equals to a new vector tree. So I'm just like creating a new object of the type vector tree. When we just say new vector tree without saying a value, it's just 0, 0, 0. But actually, what I want to do is use the plane.center.x, plane.center.y, and plane.center.z. And there we go. So now this represents the center of the plane. So if the plane that was identified was, for example, this plane right here, I'm going to instantiate the monster right here in this center. So that's basically what we need to do. I will pass this center right here. Every time that we use or we specify a center, like our position, we also need to specify a rotation as well. So I will just use here the quaternion.identity. What the heck is a quaternion? Is a data structure that represents rotation. So in computer science, we don't use usually like Euler angles as we are like used to 20 degrees. We just use a quaternion that is a cryptic thing. But the quaternion identity is basically like 1. It's just multiplying the rotation by 1. So now what I'm doing is creating a new monster. Which monster? The one that I instantiated there, the one that I assign here. So it's going to be, in this case, one of those boxy mons. Let's just see which one. This one, Anubis. Where? In the center of the plane, which rotation? No rotation. So it's basically like the same rotation that was already in the monster. All right, so this is basically it. It's just like instantiating our monster. And we are done with this script. Oh, no, we are not. There is one more thing that we need to do here. That is changing the monster exists to true now. Because it didn't exist. But now that I instantiated, it does exist. So when we capture the monster, we need to go it back to make it back to false. But that's basically it. So now we already have a logic to create random monsters on our room. Ben is asking, does that coordinate with the center of the monster asset? Yeah, if you don't yeah, that's true. It is coordinating with the center of the monster. So the monster is going to be, the center of the monster is going to be aligned with the center of the plane. That's it. So maybe you would like to move the monster up a little bit. But yeah, you are right. That's absolutely correct. All right. Cool. So now this is it. For the monster, that is exactly what we need to do. One sad thing about AR Foundation is that if we just hit play here, nothing happens. It's not able to simulate that or to do anything just in the editor. We do need to build that to the device. We can see here in the console that it says, please ensure valid loader configuration, blah, 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 lots of errors. Those are not errors. They're just basically saying that my webcam is not able to find planes. So we cannot use it. We need to build it to the device. I'm going to do that in the end of the session because it takes a minute. So while Lucy comes back and wraps up, I will build and then show you guys. But right now, let's keep moving. So that's it for the monster. Is it all right there? Thumbs up if yes. Let me see some thumbs up. Cool, perfect. All right, I see some thumbs up. So now what do we need to do? We need to create our Pokeball. We just need to create like the ball that we're going to be throwing. So let's get into it. How I'm going to do it. So the first thing is I need to create a sphere. I need to create like a ball here that is going to represent our Pokeball. So the first thing is I will right click, create on 3D object sphere. So now I have a sphere. Oh, it's cool. It can be our Pokeball. I will probably want to make it a little bit smaller. So I don't know, maybe like 0.4, 0.4, 0.4. We can experiment with that later and see how big it needs to be. But I think 0.5, 0.4 is going to be fine. It's going to be a little bit bigger than the monster. And then I will make this a child of the camera. Why is that? Because later on, I want it to be in the screen. So I just want it to be aligned with the camera every time. So we're going to be seeing that real soon here. So I will rename it to ball. So I know, or to Pokeball. And that's it. So now I have the sphere. We can make it beautiful. We can make it look more like a ball. So let me real quick create one thing here that we call a material. Right click, create material. So what is a material? It's basically like something that makes an object look like something. So if I want it make it look like, if I want to make it look like wood, I can just create a material. If I want to make it look like gold, I can just create a material. So this one is gonna be ball. We can change, if I want to assign that to this ball, I just need to drag it, and I can change the color, for example, like make it red. So this is a possibility. Or we can add a texture. So if I click here on albedo, I can select a texture. I already have a texture here that is just like a Pokeball, and now it's a lot better. So you can download those textures from the internet. Any texture that you use here is going to wrap around the Pokeball. And now we can create the script, the Pokeball. And now we can create a script here that is gonna drag, or that is gonna drive this ball, that is gonna control the ball. So let's go there. I will here go on script, right click, create, C#, and call it ball. And again, I just need to select the ball and drag this script. Remember that I said that the scripts, they only work when they are assigned to something. So I just dragged the ball script to the Pokeball here. All right, so now we need to do a couple of things. The first thing that I want to do to this ball is align that with the... Oh, before we jump into code, let me show you guys one thing super cool here. I want this ball to be physic, right? I want it to fall. I want to throw it away, apply forces to it. So we need to add something here that is called a rigid body. So if I just select the ball, click on add component and search for rigid body, now it reacts to the physics in the world. So if I hit play, it's gonna fall. Woo! It's gonna fall. We cannot see it right now, but if I select it, you're gonna see that the position is, the Y position is going lower and lower and lower because it's falling. It's just falling forever there. This is gonna be necessary, having a rigid body, because I want to throw it forward, but we can just like make this kinematic. We can just like select this is kinematic. What it does is it's just making this ball like not react to the physics right now. But we can control that on code later. So it starts kinematic, like no forces are applied to it. So it's not going to fall anymore, but we can disable this when we actually throw it. So now it's not falling until I launch that. So that's the first thing that I want to do here. Now we are going to, we need to do a couple of things here. The first thing that we need to do, and I didn't open the ball script for some reason. There we go. Let me open it. We can see that it already starts as the other one. We have the ball, start, update. There we go. And we will need to create a couple of things here. Before we jump into the code, let me try to explain here what we need to do. So we have our world. It's just here. I don't know how to draw, so just consider that just for educational purposes. Say, for example, this is our mobile phone. So we have the mobile phone here. We want our ball to start here in a place that I can actually see. And I want to throw it. I want to throw it. How do I want to throw it? I want to use my fingers, right? So I'm just like touch here, for example, and throw it in this direction. Touch here and throw it in this direction. So how do we do it? What do we need to do here, actually? We need to know where the finger, we need to know where the finger was in the screen, right? This drawing is terrible. I need to learn how to draw. So we have the phone here. I want to know, for example, where I am touching. So if I touch here, for example, I need to know where the touch started. And say, for example, I moved it this way because I want to throw it this way. I want to know this direction. So I will need the end position as well. Or if I throw it like this, I want to know the start and the end position. And then I can convert the position of the ball to the position of the word. I can throw it. But here we have one interesting problem or challenge. The screen is 2D. The screen has X and Y only because the screen is 2D, but the word is 3D. So we will need to convert those two coordinates in there. So we need to keep the start position, the end position, and we also need to convert this direction to something 3D. To modulate the force, for example, if I move my fingers really this way, I want it to go further. Or if I move it just like this, I want it to go closer. So we need to make some simple math here to determine how fast the ball needs to move. So to make it a little bit more clear, before I jump into code, does that make sense? Does that make sense? Cool. All right. So let's jump into it. Let's make it work. Nice. So let's make it work. First, I will start with all of the variables that we need. So I already know that I need the start point, right? The start point. It's basically where I start touching. I also need the end point, the place where I end touching. And I will need to calculate oops, and is misspelled. And I also need to calculate the direction. So we need one vector for the start point, one for the end point, one for the direction. So basically, we're going to be using those to determine how to throw the ball. Another thing that we need to know is basically the touch start, like the moment that the touch started. This is going to be a float. It's a number. Start time, and another one, end time. Why? Because I know how fast I am dragging. If I'm dragging really fast, I want to apply more force. If I want to, if I'm moving slower, I want to apply less force. So I need to calculate how long this gesture took. So we need those things to calculate the gesture. Another thing that I usually like to use here is a force to modulate, so I can like adjust more or less force. So it's just like a throw force that we can multiply. So I can start that, for example, with, I don't know, like 40, 50. I don't know. It's arbitrary. We need to experiment with that. So I'm just creating like a throw force that we can modulate later. I'm going to make this one public because we can like change this in the inspector later. But basically, those are the variables that we need in here. Another variable that we're going to need is a reference to that rigid body. Remember that we created a rigid body. So we need to have a reference to the rigid body so we can apply the force to it. Every time that we make something public, if we go back here to the ball, we're going to see that it does have the throw force that we can modulate. And it also requests the rigid body. I can just drag my rigid body here. So now I have a reference to the rigid body. And now we get into the interesting part. Here in the update function, every frame, I want to know if I am actually dragging, if I am touching the screen. So we need to know if the finger of the player is in the screen or not. So I'm going to use an if again. Remember that the if is to test a condition. So I want to test if the finger is on the screen or not. In the input system in Unity, there is one nice thing called the touch count. This goes from 0 to 10, telling me, no, it goes from 0 to 9, telling me how many fingers are on the screen. So if I have more than one finger, it means that I am touching the screen. So if that's happening, I will get the position of that finger. But first, I need to know which phase that finger is. So there is one thing called input.getTouch. I need to know which finger I'm getting. So I want to get the finger 0. Which finger do you guys think that is the 0? If I just say, get me the touch 0, which one is this? Or if I say, get me the touch 1. All right, Peter is already correcting there. So the finger 0 is basically the first one that touched the screen. I don't know if it's the thumb or whatever finger. It's impossible to know that. So if I have like 5 fingers on the screen, it's gonna tell me that 0 is the first one that hit the screen. So in this case here, we just wanna get 1 so we can get the first one. That's basically enough for what we want here. So I need to know what is the phase of this touch. So if the phase of this touch is touch phase dot begun, it means that I have just touched it. So I can get the initial position right here. I will replicate this code, but I will change begun to ended. So this is basically the moment where the finger is not on the screen anymore. So now I know when I start this touch, I can move it. It is still not in the end. When I remove the finger from the screen, it's going to go to the end. And then I know the initial moment, the final moment here. So we can start getting our things. So our start time is going to be the current time in the application. So time.time is basically the current time. Also, I can get the position. So the start position, what is it? It's going to be the input that get touch dot position. Remember that I said that the position on the screen only has X and Y. So it's going to give me a vector 2. I can assign that to a vector 3, but what happens is that the Z is going to be 0. The Z here is going to be 0. I actually want to have a Z, so I'm just going to get like the difference between my position and the position of the camera to be the Z here. So I would say that the start point.z is equals to my position.z, which is, I don't know, it's going to depend on where it's on the screen, minus the position of the camera. So camera dot main dot position dot transform dot position, actually dot position. Why do I need to write dot c? This whole thing here. So camera dot main is the main camera in the scene. We only have one camera, so it's gonna be our AR camera. This one right here. It's gonna be this one. It's not going to be this one because it's not tagged as main camera. So I need to tag that as main camera. So the camera.main just gets the camera that has the main tag in it. The transform is this component here, the component that has position. The position is this component of the transform, and then Z is this. So right now you might say, okay, this is 0. Why do we need to do that calculation? This is because the camera is moving. When I move the mobile phone, the camera moves as well. So I need to actually get the position of the camera. The next thing that I need to do here, and this might look a little bit weird, but remember that I want to have the position in the world. This position here is a screen position, is a 2D position. So what I want to do is convert that to a world position. The way we do it is using the camera. There is a very useful function that is the screen to world point. This one gets a point in the screen and converts that to a point in the world. They are not the same, even though they are aligned. So if you think about it, we have the world here. We have the camera here. This is to the position. It corresponds to some position in the world, but they are not the same because this is 2D. This goes from 0 to the resolution of my screen. This goes from 0 to the resolution from my of my screen, while the word go from 0 to whatever, to infinite. So I just need to convert those two. This function does that real easy for seeing here. And then I will say that the rigid body dot schematic is equals to false. So as soon as I touch the ball, I want the ball to react to the physics in there. So that's basically the first thing that we need to do. So now, perfect. I collected everything that I need when the screen or when I started touching that specific position. I know where the point is started. So now I need to do the logic for the end here. The beginning is going to be really similar. So the end point is going to be equals to this the same thing. I'm just going to copy that. The end time is going to be the same thing as well. So my end time is going to be exactly the same thing, time.time. So now I have the start time, I have the end time, and there we go. So for the position, I will need to do the same calculation. So I'll just like copy this. I will replicate this, just like getting a Z because it's 2D. So getting that to be 3D. I'm going to convert that again. So basically the same thing. Oops, but there is one thing here that I cannot copy. This is actually endpoint, endpoint, endpoint. Same logic, but now for the end point in there. And now I can calculate the force. I can basically calculate the magnitude, the difference in between those two those 2 points in there. So I will create here well, actually I already have a direction, right? So my direction is going to be equals to the end point and minus the start point. Not sure if you guys are that familiar with vectors, but basically what I'm doing here is I have here the world, I have here the camera, I have the start point, I have the end point. When I subtract the end point for the start point, I have this vector. This is a direction. So vector 3, they represent points, but they can also represent directions. So now I have this direction. The problem with this is if the points are really close, this direction is going to be smaller. If the points are really far, they are going to be really big. So I will use this size as the force that I want to use. So I'm just going to say here that the direction dot z is going to be the direction dot magnitude. So what is the magnitude? It's basically the length, the size of this vector. So I'm basically just getting it to determine how far I want it to go forward in z. And now I can modulate by the time. So I can say that the direction is equals to the direction divided by the end time minus the start time. So what I'm doing here, basically just taking the time into consideration as well. So if it takes me like really long to make this, the force is going to be smaller. If it takes me really short interval, no, it's the other way around. Like short interval, it's going to be a small vector. Longer, it's going to be a big force. And now I just need to apply this force in the rigid body. So I will say rigid body dot add force. Here I just need to pass a force, so I can say the direction. It's where I want it to go. And we can multiply that by the throw force that we created. So we can experiment with how this is going to affect the ball in there, the direction of the ball in there. Seems like a little bit of math. Does it make sense? Is it clear? Chan chan. All right, perfect. That's great. Cool. Usually people are a little bit afraid of those things, but they are really useful. So if it's making sense, it's good. There is only one last thing that we need to do. Only one last thing that we need to do, which is capture the monster. So if this ball touches the monster, we need to be able to capture that. So this is easy. This is not that complicated. So the way we do it is basically first, I need to identify that all of the monsters are actual monsters. I need to know what they are. So how do I know it? Well, I need to test something, right? So if I select all of my monsters here, you guys are going to see that they have a tag. I tagged them with a tag monster. How do I do that? I can just select any object, go here in the inspector where it says tag, and select one of the tags that exists. Of course, monster is not a default tag. So I just click it on add tag. Then I added it here. I click it plus and added one more. So now I can just select all of my monsters and tag them as tags. Another thing is, if I want to detect collisions against my monster, I need them to have the box collider, or any collider. What is a collider? It's basically an object that allows me to detect what is the hitting area, the bounding box of this monster. So here, it's basically my boxing there. The ball also needs to have one. So the both objects can have a collision in there. So that's a condition for us to detect collisions between two objects. Both of them need to have a rigid body. At least one, oh no, both of them need to have a collider. At least one of them needs to have a rigid body. There are two types of colliders, the regular ones. Those are basically like physical collisions. I don't want it to go over the doors, over the walls. So we can just use a regular collider. If we just want to see if they overlap, you can make them a trigger. So what is a trigger? It's basically a collider that is not constrained. It's not physical collider. Like they can be in the same space at the same time, but I can detect that something happening there. So now that this is a trigger, that my ball is a trigger collider, I can actually here detect if it's colliding against something. So the way it works in Unity is basically with another event. So right now we have the update, we have the start. We're going to use one more, that it's public void on trigger enter. So on trigger enter is a magical function in Unity that tells me that one object, this object, is in a trigger, or this object is a trigger and is already in the area of another one. So this is the collider of the other object. What I need to do here is basically check if this other is a monster. So I would say if other dot tag is equals to monster. This is because I added the monster tag in there. I will say that I just want to destroy the other object, right? So I would say destroy who other dot game object. So that's it. I am detecting the collision against the other monster, and then I will destroy the other object right there. And this basically covers that. So now we have, just a wrap up and a quick recall in here. We have one script that is interacting with the plane. So it's going to find the planes, get the center of the plane, and draw a 3D object in there. And it is also going to destroy it because we have our logic to throw the ball, detect if the ball is colliding with something, and destroying whatever monster the ball collides with. So from here, you guys can take this project and add more features, add more functions. But this is basically like the building blocks of AR. We have our AR session that is going to start the AR, collect the image of the camera. We have the AR session origin that is going to track the position and change the position of the camera here. We have the plane manager that is going to find the planes, draw them, and we can interact with them. And all of our project is already ready to go for AR. So it's basically building on top of that. So I will stop here and invite Lucy back just to wrap up. Meanwhile, I will build this project and show you guys how it looks like in my mobile phone. So I'll just share the image of the phone here as soon as it finishes building. And then we jump into Q&A. See you in some minutes.
See you soon, Jerry. Awesome. Well, hello again, everybody. Let me know if you can hear me and if you can see me. It's great to be back. Before we continue, I'd like to invite everybody to give Jerry a round of applause, because that's, I mean, do you see the amount of knowledge that guy has? I mean, it's super impressive. So amazing. Yes, lots of heart-filled eyes. Yay, Jerry, heart Jerry. Awesome, cool. So it seems like everybody can hear me and can see me, so that's great. Let me know if that changes. And I'm just going to quickly wrap up so we can head over to the Q&A. So the first thing I like to do is launch our second poll of the day, which is on a scale of 0 to 10, how likely are you to recommend this workshop to a friend or a colleague? So this really helps us to make sure that we're keeping our workshops relevant, that it's stuff that you guys are looking to learn about. So I'm going to go ahead and launch it. Hello. All right, let's go here and publish poll. All right, so it's published. So if you could take 1 minute just to go over there and submit your vote, that would be awesome. All right, thank you so much. All right, so let's continue. I'd like to invite you all to our CircuitStream open house that's going to happen on June 24th at 1 p.m. PST. So again, we are going to be covering all of our courses in detail, but we're also going to be talking about our new CircuitStream certification. So we're really excited about this. We've always offered certifications, but this is definitely an upgrade. It's going to make it easier for you to share it amongst your your network on LinkedIn and industry. It's going to make it easy for people to recognize your skills. And we actually just launched it yesterday. So if you know some students that have done courses with us, you might see that they've posted their badge, their certification on LinkedIn. And so it's really exciting. So you can kind of take a peek. But we are going to be covering this a little bit more in our CircuitStream open house. So I'm going to go ahead and I'm just going to share the link so that you can sign up if you'd like to. And it should pop up in just a second here. All right, there you go. So in the meantime, I'm just going to go over all of our courses in a little bit more detail. So as I mentioned, we have our beginner course, Xor Development with Unity. This is programming focused. It's 10 weeks, 40 hours of instruction, and we have our next cohort starting on July 6th. So there's definitely still time to sign up. So in this course, you focus on how to use Unity to make AR and VR apps. We go over the C# fundamentals, which is the programming language for Unity, as Jerry, showed today. You get 4 hours of live instruction per week. You get weekly one-on-one support on a personal project, and you get the CircuitStream certification. This course curriculum was just upgraded. So in addition to your personal project, we also have the class project. It's close to 7 or 8 projects in total, and a final project. So you, let's say, graduate with a really complete portfolio. It's very, it's wonderful in terms of getting into the industry and showing it to potential employers. Dion just posted the link to the open house in the chat as well, if you're looking to, if that's easier for you to click on. All right, so similar to the development course, we have the interaction design and prototyping for XR. So it's similar in terms of the structure, but in terms of the content, it's a whole different perspective. So there's no programming here, and you're really focusing on how to understand the designing experience for AR and VR apps as opposed to web and mobile apps. What are the best practices and patterns of design applied to XR? Understanding usability for XR, and what are the techniques and tools to design and create XR prototypes. So again, we're really excited about this new course. We have our first cohort starting next week, but if you're interested, we have another cohort coming up August 23rd. All right, and then last but not least, we have our Xor Project Accelerator. So this is advanced. It's an 8-week portfolio course. You do need Unity experience, and sort of 4 hours of live sessions and live instruction per week. You get 5 hours. You do get a certification with this one as well. So with all of our courses, actually, even our C# course, which is, you get actually a badge with that one, sorry. But you do get a certification with this one. And the objective here is to accelerate the design, development, and launch of a capstone project. And our next cohort is on September 14th. All right, so I'm going to go ahead and close the open house button, but it's in the chat if you're interested. Jody is asking, we use our GI Bill to pay for these. I'm not sure what you mean, but maybe one of our team members can help you out with that question, if you can explain a little bit more. All right, so who doesn't love a good deal? So we have great bundles available. You get a lot of value, a lot of bang for your buck. And we have two different starter packs. So one is focused on development because it has the Xor Development with Unity course, and the other one is focused on design because instead of that one, you get the design course. Both of them, you also get the C# scripting fundamentals course, as well as an Oculus Quest 2 headset. So it's very complete. So that's $39.50. And then we have our Accelerator Pack, which is very similar, except that it's an advanced bundle because you get the Project Accelerator. All right, so we're all about flexibility and making this accessible for you. So we have various different payment plans, which is pretty great. And again, we do offer team training. So if you are interested in a customized training plan for your business, for your company, or you're an educator, I'm going to share the contact info of our learning advisors, of our admissions team, so you can get in contact with them, and then we can draft up a quote for you. And in addition to, the one-on-ones that are present within the courses, let's say you're really advanced and you just want to focus on a project, you can purchase packs of live one-on-one sessions with one of our experts. So we do also have the info of these packs online. And then again, you also get a discount for purchasing a pack. All right, so if you'd like to take a look at these options or download one of the syllabi to take a look, in detail what each of these courses include, you could go to circusroom.com/learning. Last but not least, these are Lucy's Angels, as I like to call them. It's Steph, Kyle, and Brendan. They're our admissions team, and they can help you out to, help you understand which course should I take and when, what's the course load, how can I manage this, what are the learning outcomes. So they're super, super helpful, super nice. And, if you're in doubt, it's always useful to kind of set up a call with them. All right, so how can you get in touch with them? You can go to circusstream.com and use the chat function, or there's also an apply now button in each of the course pages, so you can go there. All right, so I'm gonna go ahead and share also our Slack link, because we always like staying connected with our students after the workshop. So you can participate in our events there. It's always good to kind of stay connected. And then last but not least, just in terms of upcoming workshops, next week on Tuesday at 11 a.m. Eastern Time, we have Intro to AR with Indika and Steph. And then on Thursday, June 17th at 3 p.m. Eastern, we have Intro to C# again with myself and Jerry. All right, so that's it for kind of a wrap up and resources. I think that's the fastest time I've done it. I should challenge myself, to think it's super, super objective. Let me close up this screen. Hey, Jerry, how's it going?
Not bad. All right, so I'm back here. Before we jump into the questions there, let me show you guys what it comes up to. And remember that you guys are going to receive the resources in there, everything, like the whole project on GitHub. So you guys can play around and see how it goes. Don't mind the mess here. It's just my office. But that's basically, as you can see, those are the planes. They are being detected in there. It just finds the plane. This is going to be better with better devices. I'm using a really not so good Android in here. But when I use the iPhone, for example, it just finds a lot more planes. But then there we go. So we have the monster that is there. It's not looking at me. This is an improvement that we can do with code. And yeah, so I can just if I make it really long, it goes further. I can just make it like this. So it's basically what we coded in there, the direction of our finger, the beginning and the end, plus the size of it, and then the monster is just right there. Let me see if I can get it. Probably not.
We believe in you, Jerry. You can do it.
Yeah, I have been trying, but I never got that. So maybe I can get that sleeping one. Oh, that's not virtual. flipping there, not virtual.
Yeah.
But yeah, so that's it. So from this project here, you guys can move along and add more and more interesting features there.
Awesome. You can cover the programming side of things, but maybe hitting targets. Maybe we can leave that to the students, right?
Yeah. That's I need to more effort training that.
Awesome.
Cool. So let's see the question. Oh, I'm sorry.
Oh, yeah, I was gonna say the same thing as you. So if we head over to the questions. Alrighty. Oh, so I'm gonna go from order of most votes to least votes. So if you guys have any questions, you can continue to add them to the questions tab. So let's start with Anna. So Anna is asking, is there a way to publish for web AR using Unity or other high-level tools?
Well, yeah. So now with Unity at this moment, Unity doesn't support web AR yet. This is something that is really waited and everyone wants to see that maybe really soon. But with other high-level tools, yes, you can do it. So I know about A-Frame, for example, which is free. There is A-Wall, which is the most one used there for web AR. It's not free, but it's good. So yeah, there are a couple of tools out there that work with web AR, but Unity, not yet, unfortunately. There are some workarounds I've seen people doing, like with the WebXR thing that was released by Mozilla. I tested that myself. It's okay-ish. Like it allows us to do something, but it's not really effective yet. So yeah, Unity, at least for now, it's not the way to go with web AR, but maybe really soon.
And they're always changing and upgrading. So maybe this is something that will come soon, right?
Yeah. I think there are a lot of people waiting for that. So we're gonna look into that at some point.
Cool. All right. Thanks, Jerry. Thanks, Anna. So now we have Nanette. Nanette is asking, which tools are Jerry using for sketching and coding?
Oh, for coding, I was using Visual Studio. If you install Unity on a Windows, it just like suggests that you install Visual Studio out of the box. If it's on a Mac, you need to download that. Just search like on Google Visual Studio for Mac and install it. So yeah, I was using Visual Studio. For sketching, I was using Procreate on the iPad and just sharing the screen there. Yeah, so Procreate is like the fancier way to do this.
Paint?
Yeah, it's like perfect for people that know how to paint, the digital painting. That's not my case. So it's like I just use the fanciest tool for terrible sketches.
No, you were doing minimalism, it's your own style.
Yeah. But I like it for explaining concepts. Like it helps me, but yeah, nothing pretty comes from my hands here.
Awesome. Cool. Thanks, Nanette. So another question from Anna. Anna's asking, can we make the object collide with the planes detected, i.e. make the ball bounce on the plane?
Yeah, definitely. So the only thing that I need to do is to add a collider to that plane, because we are using the AR default plane, right? I think that one doesn't come with a collider. Like, oh, it does. Oh, you don't need to do anything. It already works. Yeah.
Oh,
it already comes with a mesh collider. So yeah, it does work.
Cool. Nice. Great question. Another question from Anna as well. Anna was on fire. She got all of her questions in early, I like it. I admire that. So anyways, this question is, does Unity have a higher level function for detecting touch start and end without accessing each finger on the touch count?
No, not really. So that's the highest level that we can go. We actually need to use the input system to get like finger by finger. Actually, there is a new input system in Unity. It's called the new input system. So if you search for that, it's based on actions. So the way it works is you give a name to an action. So the name can be, for example, like position start. And then you can map many bindings to that. So you can make it work, for example, with the finger, but also with the mouse and also with like a controller in the VR. So the action-based input system in Unity, it allows us to create actions that are translated to inputs, but you need to bind it anyways. So you need to bind it to the finger. The new input system is better. Like it's more flexible and it's really good. The reason why I didn't use it today is because, well, it's a thing in its own. So we would spend like 20, 30 minutes just setting that up. So maybe in a future workshop we can go over. And it's still like in preview, so it's not perfect. There are a couple of bugs in there. But I personally like the new input system a lot. It makes the cross-platform development a lot more streamlined and better. Yeah.
Awesome.
But we need to make the binding for the finger anyways. Yeah, that's something we cannot just bypass.
Cool. We have a question from, I was going to click on Edgar and then it went to Rodrigo. So, there you go. It's dynamic. Rodrigo's asking, then is it possible to activate a real item touching it through the screen?
A real item? Oh, no, wait, no. It's not that it's not possible, but just now with AR, because how do we know that it's there? So if it's a plane, for example, like a table or the wall, something like that, yes, it's quite easy. If it's an object, you need to use object detection. There is another feature in AR. So you need to classify that object to know that this thing is a mug, this thing is I don't know, like whatever. So it's possible, but it's trickier. It's not that easy to just select the real objects in there, because you need to have a virtual representation of them. So it's possible, but a little bit harder.
Okay. Maybe a second workshop as well? Who knows?
I think so, but I think so. But it's possible. We can. The thing is, object recognition right now only works with iOS. With Android, you cannot do it unless you use like some kind of machine learning or computer vision classification. But just with the tools that we are using here, it only works for iOS right now, like classifying an object. And it's cool. It works just fine, but only for iOS.
The only moment where I guess Apple users can celebrate, right?
The AR technology is a lot better in ARKit than it is in ARCore. So you can do a bunch of more advanced stuff for iOS.
Okay, cool. All right, so now we've gotten to Edgar. So Edgar's asking, when the project is ready, is there a way to export it as an APK or is it default?
Yeah, it's the default. Remember that in the beginning, I changed my my project settings to Android. So from that moment on, when we build, it generates the APK already. So that's basically what I did here behind the scenes. I just hit build and play, build and run. It just creates an APK and installs that APK on the device automatically. If the device is connected and with a USB debugging enabled and developer mode enabled, you just hit build and run. It generates the APK and installs that. And you can get that APK and publish that on the Apple Play Store, Google Play Store, or share that with your friends. So yeah, that's the default when you change the format.
Cool. And Anna has to head out. No worries, Anna. Thanks for coming. And we still have another question of yours, but you can watch the recording after for the answer. So let's go ahead to her question. Anna's asking, in Unity, the scale of the objects is absolute, or could I do something like nesting an object under the AR plane manager and scale it according to the detected plane?
That's a good question. So actually, it's not absolute. Like when we have, for example, a parent and you add children to it, the scale of the children are relative to the parent, but that strategy doesn't work really well for the plane manager. So you need to consider like the scale of your AR environment and then scale everything accordingly. So you can change the scale of the world in the AR session, for example. This is something that you can do. And then you don't need like to do what I did, like scaling each object individually. So you can change the scale of the entire AR system. So to match like Atomic or Universe or something like that. In Unity Mars, for example, they have like a drag and drop button. Like it's not a drag and drop. It's just like a slider to make it easier. In AR Foundation, you need to do that with code. But adding the things as the children of the plane manager, that's a little bit tricky. I don't recommend going that route. But the scale is not absolute. It's relative to the parents.
Awesome. All right, so let's see if we have any unanswered questions. Also, if you have any last-minute questions that you want to ask, now is definitely the moment. but it doesn't look like, Anna got that answer. Great. Awesome.
Yeah,
Glad that you could
cool.
stick around. Okay, so it doesn't look like we have any other questions. So I guess we're done. We can wrap it up here. Thank you again, everybody, for coming. Thanks to Jerry again. I'm going to, instead of clapping, I'm going to do the wave to congratulate you. There you go. And okay, so hope to see you guys on Slack and then also next week for our other 2 workshops. Thanks so much. Thanks, Jerry. Have a great day.
Bye. Thanks, everyone. See you. Bye-bye.
Bye.